Biosphere, by the way, which is the name of the company that you are running, and we'll talk about Biosphere. You guys have this really cool paragraph on your website talking about the manufacturing process. There would be no American industrial revolution without the Bessemer Steel Process. There would be no mass market automobile without Henry Ford's assembly line. There would be no personal computer without Intel's 4004. And without a revolution in the architecture of the bioreactor, there can be no biomanufactured future. Did you write that?
I think I wrote part of it. I collaborated with my co-founder on that sentence, I think.
I always like when people kind of like draw parallels from, iconic things in the past. But when most people do it, they always have like some reference to Steve Jobs, which is super corny at this point.
Right.
And I think it's cool that you were able to do that without invoking Steve.
Yeah. We tried to go for sort of a more of a historical, non-obvious context.
Yeah.
And both myself and my co-founder have read a lot of history about, the way the industries have developed. I think it is interesting just to think about technological shifts that are driven by what seems like kind of a single invention. And there are a number of them out there.
It's true. And it is funny to me that I don't think people today, when they hear like Bessemer Venture Partners, even make that connection between like, oh, that was the people that created the steel. And what I think is even cooler about it is that it wasn't like Henry Ford. Bessemer wasn't the guy that ran the company.
Mm-hmm.
He was the engineer that invented the process. And the guy that owned the company was like, that's so important to everything that we're going to name it after him. We're not going to take the credit.
That is pretty cool.
That's rare nowadays.
Cool. Yeah,
that's never done these days. That's amazing.
If it was done today, it would be the Zuckerberg steel, steel manufacturing process.
Exactly.
Anyway, so the whole point of your company is that you guys feel that you have developed something that is analogous to these iconic industrial processes that unlocked these huge industries. So what was sort of the insight that you guys had that led you to start Biosphere?
Yeah, I mean, prior to this, I was running a venture fund called Mars Bio. I'm still a GP there. But at that time, I was looking at a lot of companies in biotech and in biomanufacturing, a lot of product companies in particular. So these are companies that had invented some new product that was made from cells or from microbes, and going after industries like food and nutrition, advanced materials, energy, some medical stuff as well. So it was clear that there was a lot of innovation happening. These tools to engineer genetic code and make new products were kind of getting disseminated out into the world. And many people were innovating. Many people were talking to customers and sort of getting some traction with folks who wanted to buy these products. You have some, say, new engineered protein that could be used in food or something. So they actually were finding traction from a commercial perspective. But what was really challenging was, especially in cases where they were going up against some incumbent product, and even if you're just going into any sort of CPG or consumer industry, price is kind of king. It's really tough to launch a product that is substantially more expensive than whatever its alternative may be, unless it has some insane value proposition. So,
and if it's commodity, there's really no value proposition.
I mean, and at that time, sure, people were saying, "Oh, well, it's more sustainable or something," but that really wasn't enough to get these things sold. If the price
if it costs 10 times as much,
exactly,
or even twice as much.
And a lot of that price was driven by the cost of manufacturing, and a lot of these innovators had sort of put off the idea of manufacturing and said, hey, we're just going to innovate on this new product and it's going to be so exciting and sexy that manufacturing will figure itself out. Maybe there's other industries where that works in. The sort of manufacturing puzzle is slightly more solved, but definitely in biomanufacturing, that's not the case. So I was seeing all of these seemingly interesting products run into this brick wall of scaled manufacturing and realizing that, the product development, actually, that's not the challenge or the problem. The manufacturing is the problem. So wanted to try to work on this problem. And I, spent probably about a year while at Mars Bio looking for a company that kind of fit that paradigm or that narrative, focused solely on the manufacturing and in particular manufacturing at scale. Didn't find it. So met my co-founder and he and I just kind of got to talking about what can we do in this space. And we thought deeply about, why is biomanufacturing so expensive? What is driving this? What are some potential technology levers that can make a difference? And, what has changed What's different today than people had maybe 5 or 10 years ago? Like what has changed that we can actually apply to this market? And so we really focused in on sterile design as a key constraint around these facilities. So in biomanufacturing, you basically only want your biology of interest to grow. You don't want anything else to grow in your facility, really.
No contaminants.
No contaminants. You want to just grow your one bug. And a lot of times those bugs are engineered and they're really sensitive, so you got to kind of protect them. So that's very different than chemicals manufacturing or hardware manufacturing. You don't really care about sterile conditions in hardware manufacturing. It's totally fine if there's lots of microbes around. It's not a big deal. So this is a very unique constraint of biomanufacturing. And people have tried to solve it in a few ways, but it's still a major problem and a major cost driver. That's kind of what we found. So we wanted to focus on that as like the key issue.
And so how was that problem addressed previously, and how are you guys thinking about addressing that problem?
Yeah, previously it was addressed using basically high pressure, super hot steam.
Kill anything that
Just
happened to be
burn
living
it
on
with
the
fire,
inside of the
basically.
vat. Okay.
Yeah, just fucking burn it with fire. Go hard as possible, without any regard for, any sort of mediation there. Just going hard with high pressure, hot steam.
Okay.
And this is how the vast majority, pretty much all large scale biomanufacturing plants use high pressure steam. And that requires massive steam boilers, which consume a lot of energy, electricity or natural gas, miles and miles of precision welded steam piping to every single port and valve in these systems. So if you look at a picture of these steam sterilized systems, it's just kind of a rat's nest of pipes, each of which has to be kind of custom installed and inspected and traced. And then the reactors themselves have to be constructed out of a particular kind of steel, be very thick, because you're filling these with high pressure steam, holding them for a number of hours, and then cycling on them up and down to temperature, hundreds or thousands of times over their lifetime.
Right.
So it's a very harsh process.
Okay.
Yeah.
So does it work though? Does it get rid of the contaminants?
It's not perfect.
Okay.
There pretty much anybody who runs one of these facilities complains about contamination, and contamination does occur. As in there's certain kinds of microbes or there's certain kinds of contaminants that maybe are more prevalent than others, but it's not perfect. It's kind of the best that we have today.
And my understanding, correct me if I'm wrong, is that the contamination is like a particularly insidious problem because if you go back to that beer analogy and you imagine like a big old beer vat, it's not what you guys are using or what other biomanufacturers are using, but something of a similar sort of scale. You put the ingredients in there, and the biomanufacturing process is not something that takes like a few hours. It can be like a multi-week process. And if you just have a little bit of a contaminant in there, it may, multiply and grow over time, but you don't even know that you're contaminated until maybe week 3. And so you've lost a whole entire batch and you've lost a whole entire month of grow. So you really got to make sure it's sterile and it's not like something you can immediately sort of sense and rectify. Is that more or less correct? Or
totally. Totally. Yeah. And I mean, I think,
so you really got to make sure that it's sterile. Were you going to say something, Sam? Sorry.
I wanted to ask a little bit of a clarifying question because you had mentioned before that for specific products, it's not the product development that's the issue. It's like the scale manufacturing that is, and you've identified that the sterilization problem is part and parcel and probably core to the scaling problem. Is it correct to infer that there are some products where contamination matters less? Because it sounds to me like there is a pipeline of products that technically could be, available and produced this way, but they're not because scaled manufacturing is not available. However, it sounds like there's other products that are made this way that don't suffer the same problem.
Yeah. If you thought about a spectrum of products, there are ones that are much more sensitive to contamination and ones that may be less. I mean, the obvious sort of answer is ones that have to go into the food supply or cosmetics or certainly drugs, because you have that sort of regulatory compliance aspect where you don't want anything else in your product. On the other side of the spectrum, you could imagine fuels or plastics or like industrial products that maybe wouldn't, at least from an end product perspective, care that much. But with regards to the biology, I think that's the other aspect to consider. So if you have these fermentations, these biomanufacturing campaigns, they vary in length. Sometimes they can be a week long. Sometimes maybe they're only a day long. Sometimes maybe they're only a few hours long. the longer you go, the probably the riskier it is to have a contaminant. And, often the costlier it can be to sort of lose all that time on the machine. But the big challenge is that if you have something that's out competing your primary organism, the productivity goes way down as well. So even if you're making a bioplastic and maybe you can kind of run semi-sterile, you don't really care what's in there, your productivity is probably going to go way down with the assumption that this sort of adventitious organism outcompetes your organism that you actually want to grow.
I see. And so I can imagine that what you're working on at Biosphere is first and foremost the hardware innovation. There's obviously probably some software components to that, but in addition to that, it sounds like a lot of process engineering optimization. Would that be correct?
Mm-hmm. Yeah. The sort of soul or the starting point for us is using UV to sterilize instead of these other methodologies. And that sort of opens up a lot of different avenues for exploration, redesign of the reactor, process engineering, all that kind of stuff.
So the UV instead of steam, no more steam. And I guess plenty of advantages to using UV to sterilize. How come that isn't something that people were doing already? Because, I mean, it's somewhat known that you can sterilize things with UV. I think you can buy like UV phone sterilizers and stuff.
Yeah. I mean, I will say when people hear the idea, they're sort of like, well, that seems obvious, which I don't think is a bad thing.
No, not at all.
And I will say also that sort of the why now answer as well is that UV technology has come a long way in the last 10 years. In particular, during COVID, there was a lot of innovation and investment in UV technology to sterilize surfaces and sterilize hospitals and stuff like that. Particularly UVC, which is the sort of wavelength of UV that we use that is safer, but also really good at killing microbes. So there was a lot of innovation that kind of happened over the last few years that supported the process that we've taken on. But yeah, one of the reasons people haven't done it, I guess, is it is a very risk-averse industry in general. So you see this in a lot of places in biology where there is some black magic, and people follow a particular protocol. And a lot of times they don't know why they follow that protocol. They just do it because it worked, for some grad student 10 years ago, and they keep doing it. And it is because biology is so complex. It's not, it's not a human-built system. It's a, sort of this alien system that evolved over 4 billion years. It's insanely complicated. So there's a lot of black magic around biology because we don't really understand it in a lot of ways. So I think when it comes to biomanufacturing and worrying about contamination, there's also some black magic too. It's like there are traditions, there are standards, there's ways of doing things that have worked in the past, and, if it ain't broke, don't fix it. So there's a little bit of that mentality.
Yeah, and I would also imagine if someone has spent tens of millions building a big old steam system, they're not going to want to throw that out the window either.
For sure. Yeah. So I think there's also that aspect, which is that there's infrastructure that exists today that will, still be steam in 10, 20 years if it's still operating. Like the expectation isn't that existing infrastructure would be retrofitted. Because, if you can sort of, again, retain those facilities, operating them for a number of years, and it's already sort of fully depreciated, then you might want to just keep using those production assets. That's totally fine.
And so with this new tech, this UV sterilization and all the potential unlocks that it gives you, what do you think, obviously it probably varies product to product, but how do you think that the manufacturing cost will decrease? Is it like, percentage points? Is it order of magnitudes? What's kind of like your grand epic vision for how much biomanufacturing this will unlock?
Yeah, I mean, I think the goal at scale is to try to reduce costs by like 10x. And it does depend a lot on the product, and it depends a lot on the scale. So obviously, the bigger your facility, the sort of better you're doing in terms of your process economics. And then some products have, particular challenges in terms of, well, how much product is made in a given liter of broth? How do you process it after the broth is made, the downstream processing? So there's a lot of nuance from one product to the next in terms of, value and how much savings UV can allow for. But I think UV opens up this universe of really redesigning bioreactors in a new way, thinking deeply about how those integrate with all the other systems in the plant. And then, in addition to all this, sort of adding the layer on of modern process control, automation, sort of building a 21st century company in this space, which has some value as well.